Today we're going to review for your conceptual unit, what are we in, 6? Okay, test. So, number 1. It says, find the amplitude of the function and use the language of transformations to describe how the graph of the function is related to the graph of y equals cosine x. Well, the negative, or the amplitude, is going to be the absolute value of a, so the absolute value of -5 is 5. And then to get your transformations, that negative in the front is going to reflect over x, and that 5 is going to be a vertical stretch by 5. Okay? All right, determine the period of the function. Period for sine and cosine is 2 pi over the absolute value of b. So if I figure out my period, it's 2 pi over the absolute value of -2, which is 2 pi over 2, which is just pi. And then your transformations, that negative on the inside is going to reflect over y, and the 2 is going to be a horizontal shrink of, flip it over, 1/2. Okay, graph one period of the function. Use your understanding of transformations, not your graphing calculators. All right, this is a cosine function. All right, so normally cosine, we should do the math. The period is going to be 2 pi over b, which is 2 pi. So my scale, cut it in fourth, is going to be, sorry, I shouldn't write it up there, 2 pi over 4, which is going to be pi over 2. So if I was graphing this would be pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. My amplitude is 1.2, so let's mark this as 1.2. Well, let's go a little bit above. 1.2 is there, -1.2 is there. Cosine starts at the amplitude. Because of the negative, we're going to reflect over x. So I'm going to have my first mark at -1.2, then a 0, then up to 1.2, then a 0, and down to 1.2. So that should be what my graph looks like, which is this one. What did I do wrong? Oh. Yeah, I'm right. It's this one. You got to look at the scale. Okay? This one only, right here is pi. Well, here's my pi. So again, it comes down like this and up to here. That's all they've graphed. They didn't graph this part. And then they repeated it on this side, which would do this. That's where they got that graph. Okie dokie. Alright, and there's it on the graphing calculator that we're not supposed to use. Alright, the graph of sine x is shown. So here's mother sine. Which of the following shows the graph of y equals 0.5 sine of 3x? We could do all the math if you want, but if you just use your transformations, this is going to be a vertical shrink. So this has to be littler, like squishier than this. These waves are bigger. These look like half the width of those, and this is just stretched out this way. Okay? And actually, we're going to have a horizontal shrink of 1/3, which means it's going to get squishier, pushed in more to each other, not stretched out from each other. So it's got to be B. Okay? Alrighty. And there it is. Identify the maximum and minimum values and the zeros of the function in the interval -2 pi to 2 pi. Well, you know your maximum and minimum is your amplitude, your positive amplitude and your negative amplitude. To get your zeros, you need to graph it. So my period would be 2 pi over 1, which is 2 pi. My scale would be 2 pi over 4, which is pi over 2. So if I was graphing this, I'd have 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. And if I graphed this, I would start at my amplitude, then my 0, then my amplitude, then my 0, then my amplitude. And now I can tell where my zeros are. They're at 1 pi over 2, 3 pi over 2, and it would go on and on and on, actually. It's going to be all the odd pi over 2s. So there's my zeros. And it'll be the same on this side too. So that's the plus and minus. Okay. Alright, so identify the maximum, minimum, and the zeros of this function. For sine, your amplitude is 1, so the maximum is 1, the minimum is -1. To get my zeros, I need to graph it. So my period would be 2 pi over b, which is 2 pi over 4, which is pi over 2. My scale, I can't spell today, my scale is going to be pi over 2 divided by 4, which is going to be pi over 8. So if I plot that, I'm going to have 1 pi over 8, 2 pi over 8, 3 pi over 8. I need more room. 1 pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8. If I'm graphing sine, I'm going to go starting at 0. There's no reflection, so I'm going to go up amplitude 0, down amplitude 0. And it does this. So my zeros are at 2 pi over 8, at 4 pi over 8, at 6 pi over 8, at 8 pi over 8. Alright, so if I reduce these, this turns into, and these are all going to be plus or minuses. So this would be plus or minus pi over 4. Oh, and at 0, obviously. This is going to be plus or minus pi over 2. This is going to be plus or minus, if you divide by 2, that's going to be 3 pi over 4. This is going to be plus or minus pi, and then you would just keep going. Well, there's my 0, my pi over 4, pi over 2, 3 pi, and so it's got to be this one. Okay? Because they wanted all the zeros in the interval from -2 pi to 2 pi. Alrighty? So, there's my graph. Alright, construct a sinusoid with a given amplitude and period that goes through the given point. Your amplitude is 4, your period is 3 pi, and there's your h and your k. Alright, so if I'm writing this one, I'm going to plug in y equals 4 sine. My b, to figure that out, well, period equals 2 pi over b. They gave me the period, so 3 pi has to be equivalent to 2 pi over b. So multiply by b, 3 pi times b equals 2 pi. To get rid of, to get b alone, divide by 3 pi, and you get b equals 2/3. So I have 2/3, and then x minus h plus k. The zeros I don't need, and distribute the 2/3. I get y equals 4 sine of 2/3 x. Easy breezy. Alright, state the amplitude and period of the sinusoid, and relative to the basic function, the phase shift, and the vertical translation. Alright, your amplitude is the absolute value of -4, which is 4. The period is going to be 2 pi over b. In this case, b is 1 times x, so that's b. So my period is 2 pi. The phase shift, I don't have to factor b is 1, so I don't have to factor that out. So that's my phase shift with the opposite sign. So it's pi over 4 to the right. And then this is your vertical translation, which is going to be 6 units up. Alright, and there you go. Alright, your tide one. Did I not put all the things up? Oh, there they are. Okay, so it says on a particular Tuesday in a coastal town, the high tide occurs at 9:12 a.m. At that time, the water at the end of the pier is 11 feet deep, so the maximum tide is 11. At 3:24 p.m., it is low tide and the water is only 5 feet deep. Assume that the depth of the water is a sinusoidal function of time with a period of half a lunar day, which is 12 hours, 24 minutes. Alright, the first thing I know I've got to do is change all this time. You can't have minutes. So if I take 12 divided by 60, 9:12 a.m. is going to be 9.2. 3:24, take 24 divided by 60, this is going to be 3:24 p.m. is the same as 3.4. And your period is 12 hours, 24 minutes, so 24 divided by 60 I just did that, is going to be 12.4 hours. Alright, so now that I've got all my time switched over, to find my amplitude, I'm going to take my maximum, which is 11, minus my minimum, 5, divided by 2. That's going to be 6 divided by 2, which is 3. To find my C, I'm going to add them. So 11 plus 5 divided by 2 is 16 divided by 2 is 8. Time of high tide is 9.2. B equals the 2 pi over the period, so my B equals 2 pi over 12.4, which reduces down to pi over 6.2. So if I set up my sinusoid, I'm going to have, if I'm going to use high tide, so I'm going to use my cosine function. So I would have f of t equals a cosine parentheses b pi over 6.2 parentheses t minus 9.2 plus 8. There's my function. So now that I have a function to model my high tide, low tide, they want to know at what time on this particular Tuesday does the first low tide occur. So I did my little graph. Sorry, I'm writing all over it. I did my little graph, alright, and I want to know when is the first time it's low tide. So after I graphed it, I went to the first minimum, and I got this, at x equals 3.0000, then the low tide was my 5 feet. So that means it's at 3 hours past midnight, which makes it 3 a.m. Okay, so then it says, what was the approximate depth of water at 5 a.m. and at 10 p.m.? We can do the math. We can plug in 5 for time, and then we'd have to plug in 10 p.m., which would be 12, 11, 12, 13, 14, 15, 14, 15, 16, 17, 18, 19, 20, 21. This would be 22 hours. So you could plug in 22 hours for time, excuse me, and do it algebraically. I did it graphically since I already had the function typed into my calculator. I just went to table, and at 5 a.m. the depth is going to be 6.41 feet. At 10 p.m., which is going to be at 22 hours, the depth is 10.94. And then, what is the time, the first time on this particular Tuesday when the water is 8 feet deep, which is actually high tide. So I'm going to type in my function for y1, and for y2 I'm going to do 8. And the first intersection point after midnight is right here with those coordinates, which means 6.1 hours after midnight. Well, I want to know the time of day, so how many minutes is 0.1 hours? So 0.1 times 60, and you get 6, which makes this, so 0.1 hours is 6 minutes. So that would be 6:06 a.m. Oops. a.m. Okay. Alright, next it says graph 2 periods of the given tangent function. You have to choose the correct graph. Again, you guys can do this pretty much based on transformations. There's no reflection, so there's no way it can be C. That would be a cotangent function. This one has to be rising to the right. Now, if I don't have a phase shift, if there's nothing inside parentheses being added or subtracted, there's no phase shift. If there's no phase shift, tangent has to pass through 0, 0. So it's got to be B. But let's do the math because it's important that you know how to graph these things. Alright, my period of tangent is pi over B. So this one's going to be pi over 5. I'm going to make my scale. I'm going to divide that by 2, which gives me pi over 10. So if I was graphing this, I'd have pi over 10, 2 pi over 10, 3 pi over 10, 4 pi over 10. Okay? So then if I'm going to do tangent, if there's no reflection, then your tangent has to pass through 0. So first 0 sine is your first 0 of tangent, right there, and then it's going to be every other line. And it's tangent, so we rise Now the 1/3 is going to shrink it, so it's going to be pretty wide curves here. It's not, in other words, you wouldn't just do this. They're going to be pretty wide because of the 1/3 that shrinks it. Okay, so there would be your graph, which if you look at pi over 10, there's my asymptote. Every other line is my 0, so it's got to be B. Alright. Graph 2 periods of the given secant function. Alright, well, secant is reciprocal to cosine. Yes, secant is reciprocal to cosine. So I'm going to treat this kind of like a cosine. So my period is going to be 2 pi over b. My scale is going to be 2 pi over 3 cut in fourths, which is going to be 2 pi over 12, which is going to be pi over 6. So if I set up my graph, 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. Alright, and if I'm going to do cosine, you would have an amplitude, then a 0, then an amplitude, then a 0, then an amplitude. And then what you do, once you mark out your cosine graph, is wherever there's a 0, you have an asymptote. And wherever you have an amplitude, you have your parabolas in between. So I've got to find one that has an asymptote at pi over 6. This one does. This one does. I can't read that one. This one does, so that's not helping me. They all do. Alright, so they all have the right scales. I need the one that has this starting at 2, a height of 2. Oh yeah, they're counting by 2. So 2, 4, 6, 8, 10. So there's your amplitude, which does this. Negative 2 does this. Positive 2, negative 2, positive 2. It's got to be B. Yeah? This one is shifted over. This would be a sine, and this would be a sine. This would be a negative sine. Alright, so graph the function over one period of the interval. We've got a cotangent. Cotangents have to, well, I guess that could be a cotangent, but that would have to be really, really stretched, and mine is not going to be stretched. It's going to be shrunk. So it's not going to look like a straight line. I don't know what the heck that is. So it's between these two that looks even remotely like a tangent or a cotangent wave. Cotangent with no reflection has to fall to the right. This one's rising to the right, which would make it a negative. So that's not it, which means it's got to be that one. But let's do the math. If we're graphing cotangent, the period is pi over b, so it's going to be pi over 3. To get my scale, I take pi over 3 and cut it in half, which is going to be pi over 6. So if I start graphing this, 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. For cotangent, hold on, if I was pretending cotangent cotangent has zeros at the same place that cosine has zeros. So if I mark off cosine, it would be, that's only 1/5, but it would be that. Well, everywhere that you have a 0, you have an asymptote. And so everywhere, sorry. Everywhere, the wave has to be here. Everywhere, cotangent has a 0 at the same place cosine has a 0. So your amplitudes of cosine are your asymptotes. I apologize. And then cotangent has to fall, and it's going to be squishy because the 1/5 is a shrink. So I need one that looks like this. Well, if you look right there, half of pi over 2 would be pi over 4. I'm not sure what's going on with the scale there, but it's got to be D. Pi over 2 pi over 4. I don't think that, no, the zero's not right there. The 0, oh, I don't know, it does look like it, doesn't it? I don't know, pi over 6, I think it crosses a little earlier. I see, I don't like their scales. They don't count by what the function is set up by, but it's got to be that one. Alright, find the graph of cosecant of x over 11. Alright, and again, with the scales thing here, you see how they're graphing on, they're not counting by intervals of pi, they're counting by ones? That's going to affect the way your graph looks. So let's do this normally. Cosecant is reciprocal to sine. So if I started graphing this like sine, my period would be 2 pi over b, which is 1/11. That would be 2 pi times 11 over 1, which would be 22 pi. Okay, my scale then is going to be 22 pi over 4, which if I reduce is 11 pi over 2. So if I was graphing this, I would have 11 pi over 2. The next one would be 22 pi over 2. The next one would be 22 and 11, 33 pi over 2. The next one would be 44 pi over 2. Alright, and if I was graphing this, cosecant is reciprocal to sine. So if I pretended to graph sine, I would do 0, altitude 0, altitude 0. Cosecant has asymptotes at zeros and parabolas at amplitude. So this would be what your graph looks like. Now, what the heck? It looks like, what the heck is 11 pi over 2? Well, 11 pi divided by 2 is approximately 17.27. Alright, so this graph is only going out to 10, which means over here it's 17.2 something. Alright, this thing would finally start turning around and going back up. These are going to be very, very wide because this is actually going to be a horizontal stretch of 11. That's going to stretch it out huge. Alright, so there would be, it's got to be this one. These are two little. Alright, so what transformations are required to obtain the graph of the given function from the graph of y equals cotangent x? That 3 halves is bigger than 1, so that's going to be a vertical stretch. Okay, the horizontal stretch, what's touching x, that's the same thing as saying 3 halves cotangent of 1/3 x. So that's going to be a horizontal stretch of 3. And there's no reflection over x because 3 halves isn't negative. Okay, this one says solve for x in the given interval. They want you to find the angle between 0 and pi, so we're just looking up here, that has an x over y that equals the square root of 3 over 1. So if I'm looking in here, and it's got to be positive, I'm over here in the first quadrant, so if I try, well, I mean, if you're doing multiple choice, you can pick, but if I try pi over 6, and I take its x, which is the square root of 3 over 2, divided by its y, which is 1/2, keep, change, flip, I get the square root of 3 over 1. So the angle I'm looking for is, not cosine, the cotangent of pi over 6 will equal the square root of 3. So my answer is pi over 6. Alright, it says use a calculator to solve for x in a given interval. Now, here you got to be careful here. Alright, we're doing cosecant of x equals 3.8. If I type it in the calculator, I'm going to do sine of 1 divided by 3.8, and I get the 0.26013102228, which why they're calling it 0.27, I don't know, because 0 would not bump it up. But anyway, there's your 0.26. Where the heck is this one coming from? My calculator didn't give me that. Alright, well, remember, cosecant, okay, is sister, cousin to sine. So if I drew a unit circle and I plotted that, remember sine is y, and if I plotted that 0.29. I don't know where I got 0.29 from. I think I meant 0.2 point. What did I do? That just made sense, I promise. I think I meant this to be 0.26. Anyway, if y is 0.26, then you have this coordinate here, right? Which would make this angle that has a y coordinate of 0.26. Well, guys, over here, you also have another y coordinate that is 0.26. Okay? What did I do? Maybe I meant 3.8. Divided by 3. No, it's 0.26. I don't know what I did. Sine of 1 divided by 3.8. Radians. I'm not sure what I was thinking about this number, but at any rate, alright, to get the other one, alright, you have this. But how would I see that answer? I don't know what the heck I was thinking. At any rate, so when you come up here, alright, this angle would be 0.26 something, 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 yes? Oh, I know, I think I did this backwards. I should have animated this first and this first. Okay, so if you take your first answer, 0.27, and you draw that angle, okay, what that means is that has a y coordinate of 0.26. I really need to fix that because that really is not good. Again, over here you're going to have another y coordinate that is 0.26. So what you want to do is this angle would also be, this would be all the way over to pi, but then I'd have to back up and take off 0.26. So if I take pi and I subtract my answer, that's where they get the 2.88. Okay. Alright, so anyway, you got to be careful of your quadrants in there. Alright, find approximate solutions for the equation in the interval negative pi to pi. So if I type this in for y1, whenever you're told to find approximate solutions, you're setting two functions equal to each other. So I'm gonna type in tan x for y1 and 2 times 1 divided by sine x, because that's cosecant. And then if I graph it, I get these pictures, and then I calculate the intersection points here and here. Well, this one has coordinates at negative 1.14, blah, 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 blah. And this one has coordinates at positive 1.14, blah, 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 blah. So those are your solutions. Alright, graph f of x for from negative 2 pi to 2 pi. And state whether or not the function appears to be periodic. Well, if you graph it, you get this picture. And does it appear periodic? If you pick up this half and set it on top of this half, does it look the same? Yes. So yes, it's periodic. Okay. Graph the given function again and state whether or not it appears to be periodic. If you type that in, you're going to get a graph that looks like this, and no. If you took this half and redrew it over here, it does not look like this half, so no, it is not periodic. Alright, find the domain, the range, and the period of the following function. Sketch a graph showing 4 periods. Alright, so, let's see, for the domain, if I graph this, okay, and I should probably do it by hand, but if I graphed this, your cotangent function would look like this. But what happens is they have to take off the negative part and push it up because of the absolute value. So it takes everything below and pushes it up, which means I'm going to end up with this looking kind of graph. Okay, so if I graph it, alright, I counted by, I went from negative 2 pi to 2 pi, and this I'm counting by pi over 2s. So that mark right there is pi over 2. This one would be 2 pi over 2. This one would be 3 pi over 2, 4 pi over 2, so on and so forth. Okay? Which means that your domain is a set of all real numbers except for, why is it pi over 2? What am I doing? Alright, let's start over here. Alright, so if I was just doing cotangent of 2x, my period would be pi over b, which would be pi over 2. There's your period. If I made a scale, then, oh, I'm a schmo, that's the period. I'm an idiot. Alright, your scale then would be pi over 2 divided by 2, which would be pi over 4. So when I graph this, I have 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. Cotangent, if I look at cosine, if I graph cosine, it would be like this, then like this, then like this, then like this, then like this. So for cotangent, you have asymptotes here, and that here, and here. And then your wave would fall to the right, but this gets moved up. This bottom half gets moved up, so on and so forth. So there we go. You can see that you have the domain as the set of all real numbers except for this would be pi over 2, if I reduced it. This would be pi. Okay, this would be, the next one would be so on and so forth. So, if you've got 0, then you could call this 0 pi over 2 if you want. So it's saying at these pi's over 2's, you're at any pi over 2, because I could call this 2 pi over 2 if I wanted to. And then the next one would be 3 pi over 2, and the next one would be 4 pi over 2. So you're going at all pi over 2. 0 pi over 2, 1 pi over 2, 2 pi over 2, 3 pi over 2, so on and so forth. Your range goes from 0 to infinity. We already did the period, and the graph that matches it would be that one. Okay? Alright, find the domain, range, and period of the following function. Sketch a graph showing 4 periods. Alright, so we have, this is our graph. Your domain is a set of all real numbers because this thing is continuous. There's no breaks, there's no jumps. The range is -1 to 0 because your amplitude is still 1, which if it wasn't whatever. Alright, so this is only going to go as far down as -1, and it's going to continually oscillate between -1 and 0. So the range goes from -1 to 0. The period of the function, well, that would be 2 pi over b, but because of that fourth, well, if I graphed this, I don't know what I went from, 0 to, I'm going to assume I went from 0 to pi. Maybe I should put that on there, did I? No, I didn't. Alright, I'm going to assume I went from 0 to pi, and this is, no, I didn't. This would be, sine That would be 1 period, yeah. And again, pay attention to how you graph it, because again, you want to wait until you get to, you got to go 0, amplitude 0, amplitude 0. That's 1 period, 4 marks, and that's from 0 to pi. So my range, or my period is pi before it starts repeating. And there's my graph. Alright, determine whether f of x is a sinusoid. Well, it's a sinusoid if they have the same periods. The period of 3 sine x would be 2 pi over 1. The period of 5 cosine x would be 2 pi over 1. They have the same period, so yes, it's going to be a sinusoid. And you can see it repeats, so it is. Okay, this one, if I take the period of this one, it's going to be 2 pi over 2 pi, which is just going to be 1. If I take the period of sine 4x, that's going to be 2 pi over 4, which is pi over 2. These do not equal, so no, it's not going to be a sinusoid. Alright, let f of x equals 3 cosine x plus 2 sine x. Find a, b, and h so that f of x is approximately a sine of b times x minus h. So they want me to take this and write it as a sinusoid. We're going to do this graphically. Alright, so if I type this in and graph it, the first thing I need to do is figure out my amplitude. So go to any of the maximums, or minimums for that matter, and if I calculate that, I'm not looking at the x-coordinate, the height is approximately 3.61 if I round. Okay, to get your b, you want to find the closest intercept, or I'm sorry, the h, you want to find the closest intercept to the x-axis, which is, if I calculate this intersection point, this 0, I get negative 0.98 if I round. Alright, and then to get your b, it's going to be the same period as their period, which his period is 2 pi over 1, 2 pi over b, right? So b is 1. Here it's 2 pi over b, b is 1, so b is 1. Alright, so then they just made you find it, but you could actually write it. My function would be 3.61 sine 1 times x minus 0.9, no, minus a minus would be 0.98. Alrighty? Alright, it says identify the damping factor and tell whether the damping occurs as x approaches 0 or as x approaches negative infinity. Well, if we graph it, you can see that it is damping. You got these big waves here, and then they get shorter here, then they expand back out. So the damping factor, if you see damping, then the damping factor is whatever touches the function. So my damping factor is 3x squared, and it damps as you approach 0 from either direction. Okay. Alright, for the given function, graph both f and plus or minus its damping factor in the same viewing window. So I type, excuse me, they wanted the positive damping factor, 1.4 to the negative x, and the negative damping factor, which is negative 1.4 to the x, and then the function, I put that in the middle, and you see where I get this graph, which looks like that one. Yeah? Alright, find the period and graph the function over a 2-period interval. Well, the period of this guy is going to be 2 pi over 3. This is not going to be a sinusoid because this would be 2 pi over 2. They're not the same, so it's not going to be sinusoidal. Alright, but if I graph that, I get this picture, which looks like this guy. And then the period, man, I should really put my window here. I went from negative 2 pi to positive 2 pi. And if I pick up this half of the graph and put it on top of this half of the graph, they match, which means from here to here is 1 period, which is going to be 2 pi. So this one is periodic, but it's not a sinusoid. Alright, so graph the given function f of x over the interval negative 4 pi to 4 pi and determine whether the function is periodic, and if it is, state the period. Well, does it look periodic to you? I mean, if I type it in, okay, let me do that. If I type it in, you get this picture. Alright, set your window to what it tells you to. You get that picture. It's not periodic because if I pick up this side and put it on top of this side, it's going to be like this. It doesn't land on top of it, so it's not periodic. Alright, find the exact value in radians of the expression. They want the inverse tan of the square root of 3, which means you're looking for a theta that has a y divided by its x that comes out to the square root of 3 over 1. Alright, so again, from my choices, these are my choices, right? Arctan is only defined over here. So 4 pi over 3 is over here. That's not even in the right domain. Negative x over 3 would be down here, because there's positive x over 3. That would be negative pi over 3, sorry. So that one could work, that one could work, and that's not even a theta. So it's between positive pi over 3 and negative pi over 3. You obviously want a positive, so you need a positive divided by a positive, or a negative divided by a negative. But down here you have a positive divided by negative, so it can't be that one, which means your answer is that one. But let's do the math. Alright, if I check, its y would be the square root of 3 over 2 divided by its x would be 1/2. Keep, change, flip, I get the square root of 3 over 1, which is what I wanted, so theta equals pi over 3. Okay? Find the exact value in radians of this expression. They want an arc cosine, which is defined up here, that has a y coordinate of negative 1/2. This cosine is, I'm sorry, an x coordinate. Cosine is x. So I'm looking for an angle in these two quadrants that has an x coordinate of negative 1/2, which is 2 pi over 3. Yeah? Alright, this one, they want arc cosine of the sine of 5.6. Well, I have to do sine of 5 pi over 6 first. So I go to 5 pi over 6, and sine is y. So sine of 5 pi over 6 is 1/2. So now they want me to find the arc cosine of an angle that has the ratio of 1 over 2. So now I'm looking for the angle in the top two quadrants that has an x coordinate of positive 1/2, which would be right here, which is pi over 3. So theta is pi over 3. Alright, 7 times arc cosine of 1/3 x. They want you to find the domain and the range. Your domain of cosine is negative 1 to 1. What are they doing to my x? They are multiplying it by 1/3, which means we would actually multiply by 3, right? Because the translation would be a horizontal stretch of 3. So if I take the domain of cosine and I multiply both of those coordinates by my translation, the new domain is going to be negative 3 to 3. Range, cosine normally ranges between negative 1, well, the range of cosine is 0, or arc cosine, not cosine. The range of arc cosine is 0 to pi, remember, because it's only defined up here. So what they're doing to y is multiplying by 7. So if I take both of those coordinates and multiply by 7, I get 0 to 7 pi. Okay? Find the solution to the equation without a calculator. This says 2 cosine x equals the square root of 3. Well, I need to isolate this, so I'm going to divide by 2, which says cosine of x equals the square root of 3 over 2. So I'm looking for, to get x alone, I would arc cosine. So I'm looking for an angle that has an x coordinate of square root of 3 over 2. Well, this one has an x coordinate of the square root of 3 over 2, but so does this one. It also has an x coordinate of square root of 3 over 2. So my two angles are pi over 6 and 11 pi over 6. Now, they put this plus 2n pi because remember, you could do this, or you could go around 2 pi and do it again, or go around 2 pi and do it again. So any angle plus or minus 2 pi is going to get you the same x coordinate. And that's what this stuff is about. But those are my two answers. Okay? It wouldn't be this one, because you wouldn't just add 1 pi, because that would say it's this one and this one. No, it's not. Alright, so this one says find an algebraic expression equivalent to the given expression. Hint, form a right triangle. This says they want me to find an angle that has an x-coordinate of x. Well, that's silly. They're telling me I don't know the x-coordinate. So they're telling me to draw an angle that has a cosine of x. Cosine is adjacent over hypotenuse. So they're telling me to make adjacent x and hypotenuse 1. So adjacent to theta would be x. The hypotenuse would be 1. So now I got to find the other side. So leg squared plus leg squared equals 1 squared. So the leg squared is going to equal 1 squared minus x squared. So the leg is going to equal the square root of 1 minus x squared. Alright, so now that I have my triangle labeled, okay, that's what this was. I labeled my triangle that gave me a theta that had adjacent x, hypotenuse 1, and this would be the other leg. So now they're telling me to go stand there and take the sine of the angle you just drew. Well, sine is opposite over hypotenuse. So sine would be the square root of 1 minus x squared over 1, which is just the square root of 1 minus x squared. Okay, it says a guy wire connects the top of an antenna to a point on level ground. So you have this guy wire. I always thought it was called a guide wire. What do I know? Alright, that's going from the top of the antenna to a point on level ground 20 feet away from the base of the antenna. The angle of elevation is 71 degrees. What is the length of the wire and the height of the antenna? So they want two things. Alright, so obviously I'm standing here because that's the angle they gave me. If I want to find x first, that's hypotenuse, and they gave me adjacent. So that would be cosine. So cosine of 71 equals adjacent over hypotenuse. To set up for y, that would be opposite and adjacent, so that's going to be tangent of 71 equals y over 20. So if I solve these two for x and y, I have my answers. Make sure that we're in degrees. Excuse me. So I'm in degrees, so to solve for x, the first thing I'm going to do is multiply by x, which means I have x times cosine 71 equals 20. To get x alone, I'm going to divide by cosine 71. And I get x equals 20 divided by cosine 71. And I get 61.43. Okay, so the guy wire is approximately 61 feet. Now if I solve this one, multiply by 20, and I get y equals, if I do 20 times tan of 71, I get 58.08, which makes that approximately 58 feet high. Yeah? Alright, a whale watch boat is located at point P, and L is the nearest point on the shore. Point Q is located 4.7 miles down the shoreline from L, and PL is perpendicular to LQ, which means we have a right angle. Determine the distance that the boat is from shore if PQL, and I'm sure they want the shortest distance, if PQL it measures 40 degrees. So it looks like they're wanting this information. So if I'm standing here, they want me to find opposite, and they gave me adjacent. So I'm using tan. So I'm going to do tan 40 equals opposite over adjacent. So to get x alone, I'm going to multiply by 4.75. So tan 40 times 4.75 is 3.9857 equals x. If I round it to two places, that 5 bumps it up to 3.99 miles. Alright, a man is located 250 feet from an observation deck. The angle of elevation from the man to the bottom edge of the deck is 35 degrees. And the top edge of the deck is 40 degrees. So he's down here and he's looking up toward the bottom edge of the deck, and that's 35 degrees. Then he looks up to the top of the observation deck, and that's 40 degrees. What is the height of the observation deck itself? So they're actually just wanting this distance right here. Alright, so let's call this d. So whenever you got two angles, you're going to set up two equations. So I'm going to look at the great big one first, the one I'm drawing in blue. And that would say that angle is 40. The big one has an angle of 40 degrees, right? So that would say, if I'm on the big one, tangent, this would be opposite adjacent. So I would do tangent of 40 equals x plus d over 250. And I'm trying to figure out just x. Alright, so if I get x alone, multiply by 250, multiply by 250, I have 250 times tan 40 equals x plus d. To get x alone, I'm going to subtract d, and I get 250 times tan 40 minus d equals x. Well, that doesn't really help me find out x because I don't know d. So that must mean I need to do something with the little triangle. So if I draw my little triangle here in green, and I set up that function, I can say tan of 35 equals d over 250. Now I can solve it for d and plug it in there and be done. So I'm going to multiply by 250, multiply by 250. I get d equals 250 times tan 35. So if I plug that in here, I have 250 tan 40 minus 250 tan 35 equals x. So if I type that in, 250 times tan 40 minus 250 times tan 35, I get x equals 34.723, which will round to 35 feet. Okay? The bearing of the line of sight to the east end of the bridge from a point 350 feet due north of the west end of the bridge is 125 degrees. So you see my right triangle here? What is the length L of the bridge? So they're wanting this. Well, they gave me this angle is 125. What the heck? Well, how am I going to figure out this angle? I don't want an angle outside. Oh, well, that's a straight line, which is 180 degrees. If I take off 125 degrees, that makes this angle inside 55 degrees. So from there, they want opposite. I know adjacent. That's tangent. So if I do tangent of 55, I should get x over 350. Yeah? So to get x alone, I'm going to multiply by 350. So I have 350 times tan 55, and I get 499.8518024 equals x. And they want me to round to the nearest integer, so the 8 will bump that up to 500. Okay, yeah? Alright, it says a mass on a spring oscillates back and forth and completes one cycle in 0.20 seconds. Its maximum displacement is 8 centimeters. What is the equation that models this motion? Choose the equation that models displacement d after t seconds. Your displacement is 8, so that's your amplitude. Alright? Now, they give me this, it completes one cycle in 0.20 seconds. Okay? Well, let's just put it in time. Isn't that my frequency or is that my period? It completes one cycle. That's a period in 20 seconds. Alright? So, your period is 2 pi over W. Alright, so they're telling me that my period is 0.20 seconds equals 2 pi over W. So solve for W, I should call it omega. So 0.20 W equals 2 pi. To get omega alone, divide by 0.2, and you get 2 divided by 0.2 is 10. So this equals 10 pi, which goes right there. And then you got it. Alright? And we are done. Alright, so study well, my friends. And I will see you next time.